Now that we have talked about both SN1 reactions and SN2 reactions, things become more complicated when we are faced with a problem and trying to decide which reaction it is. So in both cases, what you need to have is a leaving group. The better the leaving group, the faster the reaction goes. This chart right here is Miller's best preferred way of thinking about things. We'll talk about his, and then we'll talk about Professor Pelkey's. But the idea is, the better the leaving group, the faster both reactions go. On the other hand, that's not true for the substituent pattern on the electrophile. Tertiary systems are excellent for SN1 reactions, but they cannot undergo SN2 reactions. Meanwhile, SN2 reactions prefer primary and methyl sorts of electrophiles, but the SN2 reaction cannot tolerate a tertiary system. An SN1 reaction goes through a carbocation, so the more substituted the leaving group, the better the stability of the cation that results. So primary and methyl are not acceptable. And if we have a secondary system, you'll notice that neither reaction is preferred, but instead then you have a serious choice to make. So in some sense, this chart tells you everything you need to know. An SN1 reaction happens with tertiary, an SN2 reaction happens with primary or methyl, and decisions are made somewhere in between. Likewise, nucleophiles differ. The stronger the nucleophile, the more an SN2 reaction is preferred. The weaker the nucleophile, the less likely that an SN2 reaction can happen, the more likely it's going via SN1. Solvents. They both need to be polar, no matter what, but a protic solvent favors an SN1 type reaction because it stabilizes the intermediate ion species, whereas an aprotic solvent stabilizes the transition state of an SN2. In essence, if you have this chart memorized and understand what it means, then you understand how to distinguish between SN1 and SN2 reactions. But there's a reason why I've been arguing all semester long for the flowchart approach to thinking about things. And I don't even necessarily consider this the correct flowchart for an SN1, SN2 decision type thing, because I could imagine starting in a very different place, like do we have a nucleophile at all, and so on and so forth. This, I think, really is the right way to think about things. First of all, if you're trying to size up whether a reaction is possible, a substitution reaction is possible, you might start with the question, do you have a good leaving group? If the answer is no, then this is not going to be an SN1 or SN2 reaction. Likewise, if you do not have a nucleophile of any kind, then it's not going to be an SN1 or SN2 reaction. Like I said, you can imagine generating several different sorts of flowcharts depending on your preferred way of thinking about things. If you have an alcohol, we're going to talk about a little later, especially if you're in the Pelkey group, although you'll notice that the Miller handout describes how you convert an alcohol into a good leaving group using the mesylate, tosylate, and triflate partners that I have talked about in a previous video. Alright, if you have a good leaving group, by which we mean probably a halogen or a mesylate, tosylate, or triflate, then the next question becomes one of degree of substitution for Professor Pelkey. And again, you see how this fits in with the Miller handout. A primary can only go via SN2, a tertiary can only go via SN1, and if you have a secondary, then there's a decision point possibly to be made. Professor Pelkey is using a nucleophile to decide between whether a SN1 and SN2 reaction can happen or whether no reaction takes place. Likewise, he uses the solvent to decide whether a SN1 reaction or no reaction takes place. But deciding whether the solvent is matched or mismatched is another way of distinguishing between whether an SN2 happens or not, and deciding between type and quality of nucleophile, type and quality of solvent are ways in which you can distinguish secondary systems as well. Again, the point is that flowchart thinking is a good way to navigate this minefield, but it is not the case that you should simply memorize this flowchart and use it.